Now I say that these things are actually equivalent and you can very easily move from one to the other. So you can see that easily if you just do this little computation. Let's take a look at fit 1 and let's take a look at fit 2. So if you look at these two sets of estimate, you will immediately see what is happening here. In this case, I have forcefully set alpha 1 equal to 0, that is I am taking the first variety as my benchmark variety. So what is reported here as the intercept is really the benchmark value. So the intercept always plays the role of the benchmark, and the benchmark in this case is the average yield for the plots which use variety 1. Now look at in the second version of the model the average for variety 1 and you will see the same value. 212.1 and it is 212.067. They have just reported it to different levels of precision. I do not know why the default level of precision changed. So they are actually the same number, precisely the same numbers. Now, in this version, variety 2, what has been reported is what extra do you get over variety 1. So in this case, I can see you are getting additional 35.933. So if you want to find out, so what is the average yield for variety 2, you have to start with the benchmark value, this 212.067. With it, you need to add 30.933. Whatever you get is directly reported in here, 248.0. If we just do this addition, it will be 248. Similarly, what is reported for variety 3 in the first version of the model is basically the extra contribution of variety 3 over variety 1. So from this output, you can see that variety 1 is 212.067. With it, add 9.283 and you will get this variety 3. So that is how you can get the output of one from the output of the other. That's why I call them equivalent. They are basically bijective reparametrization of the same model. In this way of writing, you can easily see that variety 1 is the worst and both varieties 2 and 3 are better than variety 1, which is possibly the default variety. That's why it has been taken as the benchmark, and variety 2 is much more better than variety 3 is. In this case, in this second model, we are really not comparing between variety 1, variety 2, variety 3. All the three numbers have just been reported. Suppose by chance I have fitted this model, this second version, I have fitted this variety 1, variety 2, variety 3 thing, and I want to get that value. How do I do it? Simple. I just call this as my intercept and subtract this from 248 to get this 35.933. Subtract the same 212.1 from this 221.3 to get this value. If I want to make variety 2 my benchmark value, then I have to do this computation, because R will never do that. R will always take the first one and make that the benchmark value. If I want to make variety 2 the benchmark value, that's also simple. You start with this formulation and from all the numbers you subtract 248.0. As a result, variety 2 will be 0, so that is forcefully set to be 0 because that is the benchmark. And you will quote for the intercept as 248.0, and you will not really quote the alpha 2 here because that is forcefully set equal to 0. So mu hat will be 248.0. Alpha 1 hat, which is the additional contribution, will be 212.1 minus 248. So it is a negative quantity. Similarly, here it will be 221.3 minus 248. So if you are given one form of output, you can always convert it to an equivalent form of output. This is often required because, as we see, softwares are idiosyncratic and they will just set certain thing equal to 0, which may not be what you want. So it's quite possible that variety 2 in your case is your benchmark thing. You want to compare everything with variety 2. So it is just a way of reporting things, that's all. So they all contain the same amount of information.